Hey, IBs and regulars, if you're listening. So we have to split now because this is an IB concept of environmental chemistry. So here's the idea behind why environmental chemistry is put into the interbaccalaureate chemistry unit is that environmental chemistry is more than just the first thing you think about with the environment, and that's climate change. We're going to be talking about climate change a little bit and the chemistry that goes into it. And spoiler alert, it's a thing. So let's say you don't believe that climate change is a thing, and we'll talk about the overwhelming evidence that says the opposite. There are so many other things that's involved with the environment in chemistry, from pollutants that we make to the chemistry that goes into mitigating those pollutants. Okay? So we live in an industrial civilization, and everything that is in your room and is in your house has been made from crap that's in the ground. And we have this amazing life because of it. So we can't knock any of the products and any of the life-saving stuff that's all around us that makes our life easier and allows us to live longer lives. And chemistry has made that happen and has caused problems and then has been used to mitigate said problems it itself has created. So chemistry is both good and bad depending on where you look at. Okay. So we're going to be looking at air pollution to start with. So this has nothing to do with climate change. This is the stuff released by human activity that causes problems to the environment. Okay. The first thing we're going to talk about is CO. This is, and you guys can fill out the notes in the little note pack that I sent out for today. This is carbon monoxide. Okay. Carbon monoxide is a product of combustion. It's a byproduct. It's toxic to humans. It actually kills us. When carbon monoxide binds to hemoglobin, so that's what this HB is, hemoglobin. Hemoglobin is this iron compound within red blood cells that attaches to oxygen. But carbon monoxide just binds more readily to hemoglobin, and it's super deadly. It basically saturates all of the red blood cells in your body with a molecule that you can't use to stay alive. I have a long story I normally talk about where there was a couple sisters that I taught. They didn't die, but their family was poisoned by carbon monoxide. And they did almost die, if not for the quick action of some family. So how is carbon monoxide made? Okay, well, carbon monoxide is made when you burn a hydrocarbon. So anything that's got carbon and hydrogen in it, when you burn it, you are making a small amount of carbon monoxide. Now, what happens normally when you burn something, and this is a reaction from Science 10, is you get carbon dioxide and you get water vapor. Now, what happens is if you start to run out of oxygen, you don't have enough oxygen to make 1 part carbon, 2 parts oxygen. You get carbon monoxide as a byproduct. And the more oxygen you run out of, and you're still trying to burn hydrocarbon, the ratio of carbon monoxide to carbon dioxide goes up. And that's the big problem, is that if there is poor ventilation to furnaces in houses, then carbon monoxide forms. If something is on fire in an enclosed space, or you're burning something in a garage or in a house, and there's not airflow, then instead of making carbon dioxide, which can kill you, you'll make carbon monoxide, which will kill you very quickly. So that's one part of air pollution made by humans, because we generally burn hydrocarbons for fuel. Now, I've got a couple memes here, probably you'll get now, where maybe you wouldn't have got before. Is this an oxygen? I made that one myself. Okay, I think I've got some more. Took the batteries out of the carbon monoxide alarm because the loud beeping was just giving me a headache and making me feel kind of sick and dizzy. Yeah, you're going to die. Here's another one. There's a red blood cell. Oh, who do I save? Oxygen or carbon monoxide? Carbon monoxide. It has a higher binding affinity than oxygen. So there's the iron molecule of carbon monoxide. It's a very complicated molecule in a red blood cell. Yeah. Okay. So yeah, it really it takes the place of of oxygen. Okay. That's too long to explain. That's also too long to explain. Okay, so if you wanted to show a reaction that would make carbon monoxide, you don't have to show how to balance it because you really don't know the ratio of it that's being made because it's a byproduct. So if we were to burn octane, first off, where would you find the formula for octane? It's in your data booklet on page 4 and 5. Octane is C8H18. I think it's a liquid, actually. Okay. And when we burn something, one of the reactants is always oxygen. We get carbon dioxide and water vapor. And carbon monoxide. Now, this is only an incomplete combustion, so I don't want you in the next unit, the stoichiometry unit, to throw carbon monoxide in there. You actually also get pure carbon, which is that black stuff that forms on stuff on campfires called soot. So you actually get pure carbon from really incomplete combustion.